My name is Harold Jones, and I have a bee in my bonnet about tight radius curves. This shed is about 19 foot 6 by 7 foot 6 inches, 7 foot 7 inches wide on the inside dimensions. In this, as I will show you, I have a double track main line, 2 stations, line side industries, a good sized loco depot and townships. None of this looks ridiculous. I can have 8 coach trains, 12, 15 wagon trains. I have 060s, 260s, 460s, 462s, 280s, 210s, all of which will go round the minimum radius curve of 3 foot. I am a one-man band, so these videos will have continuity problems. The camera work will not be absolutely top-notch, but I trust that none of that will detract from my message that it is possible. The pundits talk about a 6 foot minimum radius curve to get a 462 Pacific round. Watch my West Country later on. There's a lot of doom and gloom about buffer locking. Watch my 042 tank and auto coach later on. Basically, I think a lot of these pundits have not actually experimented, tried or tested. So my message is, as I say, it can be done, just please watch, enjoy and possibly plan. Thank you. Right, going to show you how I laid my double track in my 7-foot 7-inch wide shed. Experimenting, I came to the conclusion that you needed a new track. It's flexible, it bends easily, chairs slide, rail slides in the chairs, and a one-piece board. That way you don't have any joins, potential source of getting kinks and trouble. So I took my 8-foot by 4-foot sheet of MDF, cut it down to a 7-foot 7 by 4-foot sheet of MDF, and away we went. Before we start laying the track, we need a few measurements. First measurement is the halfway point on the width. 7-foot 7, half of that is 3-foot 8.5. So I measure 3-foot 8.5. At that point we should be starting the next part of the curve. To get how far in, we put our first track down. Now I allow roughly 3/4 of an inch from the edge to allow for swing and overhang. Using the railwood track gauge to set the 6-foot way, that gives us a width from the outer clearance to the inside edge of the sleeper of 6.5 inches. So if we measure 6.5 inches in from our halfway mark, when we finish the curve, the sleepers should be finished at right angles on that line. Right, beginning. We're going to set the inner track first because that is the most critical, it's the tightest radius. We need it accurate. It's also going to be used to gauge the outer track from. So we have our rail in position, our track in position. Simply a matter now of banging a few nails in. So I'm starting on the 4-foot edge, because if that's a baseboard join there, it's straight. It's no great problem. So we're just going to knock a few nails in. There's no great science required as to how many per inch or per yard. By the way, I apologise for using imperial measurements. It's what I learned, it's what I understand, it's what I can visualise. I think at primary school in the early 50s they taught us metric. Basically everything is in tens. It doesn't actually help you to understand what 3 metres actually looks like without converting it. So sorry, others will have to convert it if you need to. We're using initially the 4-foot track gauge. It gives us a nice easing into the curve. We don't have to actually do a lot. It is accurately cut. It is difficult to slide it in, but a little bit of persuasion and you're there. The whole thing at railway modelling, of course, is patience. The big hammer job is not quite what is needed. Right, we've started, yes, about there, and now we can knock another nail in, and away we go. Interestingly, I looked on the Gauge-O Guild website recently at the track standards, and they don't mention now a minimum recommended radius, but they do sort of coyly admit to there being track gauges in the common radius of 6 foot and 5'6". Well, 4 foot, 3'6", 3 foot. You can get them down to 2 foot. Markway, they manufacture some down to 2 foot. I'm sure a lot of other people do as well. Right, we're using the 3'6" radius curve now. Ease that in. Right, because we've now got a little bit of an a transit curve building up. If you like, it's our coarse way of emulating the ganger with this bit of chalk and string, who would also lay track basically by eye. I haven't bothered with actually working out what radius and when to change the gauges, because we're doing this empirically. An engineer's word for we don't know what the hell we're doing, but we'll keep doing till we get something that works. Apologies to all engineers. I don't plan, calculate, have a formula for the spacing of the track pins, which are Pico, by the way. I think Pico do a lot of good bits of kit. I think I bought mine, I don't know how long ago. I suppose, like a lot of us, I moved up from 00. So I had a lot of 00 stuff. So I use it. Don't see why I shouldn't. It's good kit and it works. All the old Ren track, Gem, all that, I use that. Point levers especially. If you look at the layout later, you may well see, where are they? They'll be in the on the coal mine sidings. There's a few there. They work, they're handy, and I've got them. So saving money wherever you can through reuse enables you to treat yourself to nice toys, little goodies. This is quite therapeutic really, knocking in nails. Now we're going to come up against a problem in a minute. That is, oh, well, that is another problem, that broke a drill. However, plan B, whip that out. Plug it in there, and here's one I already have ready. The problem we're going to come across in a minute is where we join the track. Now Pico, using Pico track, I'm actually using Pico rail joiners. Now, Pico rail joiners are about ½ an inch long. ½ an inch long, you're joining two curved bits of track, you're forcing that track to become straight for ½ an inch. Not perfectly straight, but straight. So it's a dog leg. So what I do, I take a Pico sleeve fish plate and cut it in two. You've got just on ¼ inch then. It's hardly noticeable as regards straightening the track. There is a bit of free play in it, but it stops, it removes the possibility of a kink. So right, now then, I think we'll stop there, because I know from experience that getting those fiddly little things on is fiddly. Right, having fiddled off scene with those very short fish plates, I've now laid the remaining part of the quadrant. Just to recap, 4-foot radius curve, bit of 3'6" radius curve, then the rest 3-foot radius curve. We're now ready to start laying the outer track. I haven't got a lot of spare yard lengths of track, so I've had to take this piece off my test track. But no matter, it's been on there so long it's got an image of where the rut track used to be. Right, we're going to use the Hayward Railwood track gauge using the inner rail as our datum point, and it's then simply a matter of, once again, knocking a few nails in and moving along, and as you see, it's gently going to be moved over and follow the curve. And we know this is going to fit because the inner one met our target of being about 6.5 inches in at the halfway point of this quadrant. So we can just bat along with this. And one thing, of course, I did say initially, and relayed the first piece, that we don't have to knock the nails in fully in case we have to adjust it. No need to adjust it, so I've knocked them in fully. That way this gauge can then slide along easily and maintain the same angle. So hopefully this outer curve will then be able to follow smoothly the inner curve. Once again, I'm not knocking these nails in fully in case I have to adjust it. I don't think I will, but it's a damn sight easy to pull a nail out if the head is protruding rather than use a pair of pincers or whatever to lift the head to get at it. Oh dear, therapeutic this. I wish I had better vision, but we're nearly there now because I haven't got any more rails. So as you can see, I'm just sort of going along, and when I sort of feel like it, if you like, knocking a nail in. There's not any real science in this. Let's make it just one nail that will go in then. Just bimble along. Now I was quite pleased when I actually finished off the inner rail, inner circuit, and I bunged a local or two on it. They did go round. So I've got a clip in a bit of my 060 pannier tank with auto coach going round, pushing and pulling, and my MOK 264 tank going forward and backwards. I would have shown my West Country class 460, but unfortunately the chip in that doesn't allow for DC running. So there we have the beginnings of a double track main line in a width of 7 foot 7 inches by 4 foot. These start off here, and that is then 4 foot. As we said at the beginning, this originally started off as a piece, one piece, 8 by 4. In my shed, as I said, the baseboards are 2'6" wide either side, which leaves something like 2'4" well in the middle, which is ideal for operating from. It is a bit crowded and you've got to watch when you're bending down because your backside sticks out one way and might knock something else. But there we are, quite pleased with it. What I will show you in the next little clip is just the clearances for locos and coaching stock on the curve. So we'll come to that in a minute. It's a tea break. Now the moment of truth. We've laid our minimum radius inner circuit of track. I've just brought in my 060 pannier tank and an auto coach. This is what I normally use on my layout in the shed. And let's just trog off gently and gently. Now then, let us push and gently. As you can see, the buffers are at the limits, but they are still doing the job. Case proven. Next up is my 264 tank MOK kit for the British Railways Class 4 MT, and as you see, it's a bit hesitant there. Well, it's not at the loco, it's me. It's worth a lot of money, taken a lot of effort. It's DCC chipped. I'm operating it off my old Duet, not quite as well as nice as it should be, and I've got a dead drop at the end, so a bit hesitant. Right, we're going to start with doing the clearance trials for coaching stock. On the far side we have a Lima Mark 1 widened by Roger Bailey, running on proper wheels and bogies. On the inner track we have a Western Wagon Works Dreadnought composite. Both these are pretty long, reasonable overhang and swing. Right, when the parallel, let's see, there we go, and as we move that along we can see it's a reasonably tight clearance, but it's a clearance. And move the Dreadnought along, and again we have clearance. One problem immediately rose its head when I started to operate as opposed to playing trains was that obviously I've got tight radius curves, I've hidden them, they're disguised. So if you wanted to stop and uncouple, you had to do it where you could get at it and see it. All the available couplings on the market for O gauge required you to stop at a defined spot which you could accurately align the stock with, so the electromagnet would operate and uncouple. The vast majority of my operations were taking place in the dark and dismal reaches underneath the station building. It was a non-starter. I went on the internet and I found a couple, not many, in G scale. Some stock I found was fitted with a relay, which is radio controlled, and that would then activate and lift the coupling and uncouple. For 00, the Keen system had a similar thing, but it was worked off the DCC socket for the lighting switch. and basically there's a very small electromagnet which fitted into a 00 tender, and it basically just lifted a link which dropped a coupling, and away you went. Right, so as I mentioned, I think before, I've moved up from 00. So many years ago, toddled down to Hatton's and buy a whole pile of Triang wagon chassis, took the Triang couplings off and fitted 3 links. Naturally, I still had a good supply of these. I've now been buying them online. So that was the coupling sorted, if you like. Operation was sorted with the keying system. I wasn't all that happy with it as regards the rope being robust. It was basically just a simple system which lifted. So I adapted it. I've got it to fit into a shunter's truck. Basically, you've got it's got its own dedicated chip which you program to the number of the loco it's hauling it. You've got a diode that converts the 16 volt AC to DC. Underneath you have a relay which is activated from the light switch, powers the diode, which then drives a solenoid which wags and unwaggles the coupling. There's one here fitted in a Lima tender. It's a bit untidy, but basically what it means is that you can drive a loco and train out of sight, stop and uncouple. Perfect. I'll show you in a minute the Great Western Prairie coming along, stopping, coupling up and uncoupling. The locos just have the bar, whereas the rest of the stock has the full coupling. It's simple, fiddly but simple, and effective. Now this is an attempt to show how my remote coupling uncoupling device works. As you can see, it's based on the old Triang couplings. The loco has the bar which is pivoted and operated by an electromagnet. So when it's operated, it drops down and the loco can move away. The beauty of this is you don't have any electromagnets, any ramps or anything else where you have to stop the loco exactly for the uncoupling to work. So this is normally used when it arrives with its B set and it goes underneath, which is way out of sight. I find it very useful, and as you can see, it's fitted at the front of the loco. There's not a lot you can see anywhere else, and there it is. This video is proving to be one of the hardest to actually do. This is showing how I adjust my chassis to go around the 3-foot radius curves. Well, there's not a lot to do to them. The main thing is clearances. Okay, on this one you can possibly see here a fillet of brass which I've put in to space the cylinders out slightly, because you can see here it's very tight, and here the piston rod tails are very tight. Now as we move it round, you can see here now it is actually nearly fouling. We've still got clearance here. Now if we pick this up, turn that over gently, you can just see on the tail rod where the front bogie wheel has worn it away. So what we'll do there, we'll file a little bit more off, and make it sort of a semicircle, which from this angle here Possibly. Anyway, you can't really see. Certainly from the front, you can't. As I said, there's not a lot to do to any of these. The MOK 264 tank, which if you like is a Pacific in reverse, I built that practically identical to the instructions. The only thing I left off, and it was hindsight, I didn't need to, as I think I've said before, was the overlays on the frames went just behind the wheels. Gave a few thou extra clearance, but I don't think I need it. And that's it really. It's basically looking at clearances, getting your wheels, getting everything so that, well, here's the bogie. Basically, as per the instruction, I try to make all mine similar to this now, with a little pivot which goes in there. That gives lateral movement but no fore and aft slop. So when we put the loco body on, adds the weight to it, and it does help to keep the wheels on the track. It doesn't take too much weight off the front drivers, but what it does do, when it enters a curve, the weight forces it down and it gives a little bit of extra help when we are going round what are very, very tight radius curves. Because I've moved the cylinders out, I haven't had to carve anything off. Only very slightly, which hopefully we can see here, at the front. You can see the shiny bits where I've carved a bit off, once again to enable the front bogie wheels to have a bit of extra clearance. Again, when you look at it side on, you can't see a damn thing. And that's basically it. It's an attitude of mind. You get your frames, you assemble them, you run them up and down here and see what happens. Don't forget the dynamics of you doing push-pull, slightly different to the actual motor turning the wheels. You know, it can be replicated. You've got, you know, you can do something like that. As I say, basically an attitude of mind. It can be done, you can do it. Make your frames up, bung your wheels in, don't attempt anything fancy at all, push it up and down and see where the constraints are, see where the tight spots are. You can feel when you're pushing it up and down, you can feel where it's binding. The next step then is to check excuse me, the clearances from your pony trucks, your bogies and your cylinders. Obviously a lot of locos, we've now got sort of a recessed bearing which is tapped through, and that gives additional clearance. What you're looking for is any joint, anything moving, make sure it's not going to foul another bit when it's at the extremities of the tight radius curve. Some of my locos, the MOK 264 tank, have got compensation. I think one or two have got springing just on the centre drivers. Quite a few others have got a bit of compensation, but quite the majority are rigid frames. No pickup, no suspension, no nothing. If you believe it can be done, you can do it. All it takes is a little time and effort to literally play with it, push it up and down, see what happens. And one of the main things I find is just replicate what Leinster did. A very, very good engineer, very good, well thought out kits. I've got quite a few of them, and basically you've got it on the track, you can feel it, and away you go. All it takes, play with it, check what the tight spots are, eliminate them, add a bit more valve gear, add a bit of this, check it, eliminate, get that going. Next stage, take it slowly and steadily and you're there. End of story. Right, the Great Western 47XX class, unadorned by numbers, lettering, pipework, handrails. Sandpipes as yet, a full complement of brake gear, and this is entering what is our tightest radius curve on the layout. Right, we'll call that a day. Just go back a little bit. Right, now we go up. As you can see, the wiring is not very tidy. The actual deck, well, don't forget it's allegedly a wagon repair site here. Look, it's going up. It's going up. Right. First floor. Now stand up. And with luck, and there we are. Another problem solved as regards finding space for everything. Right, now setting up the dog lift, relatively straightforward. The dog lift basically, as it comes, plonked down, more or less in a rough position. The limiting factor is the level and position of the top baseboard. So the dog lift is taken up, positioned roughly where I want it to be. This curved piece here is cut out of the main baseboard. Now the dog lift is taken up to its highest level. That is not sufficient to reach the top level of the baseboard. So this glorious assembly of blocks and pieces of wood and packing pieces, lollipop sticks again, are used to get this particular piece of track level at the top where the track goes onto the dog lift. Once that's set up, running, carefully aligned, we are quite restricted because of all the other tracks. So this straight away basically is a 3-foot radius curve. So when it comes down, because when it goes up it stops automatically and the tracks are level. When it comes down, it stops at the bottom automatically. So once again we need then to adjust the level of this low level baseboard where the loco depot is. Originally I put the baseboard in before I'd actually arrived at or bought a suitable means of getting from one to the other. You can see here that's where this baseboard level was. Relatively simple matter, just unscrew everything. Don't forget, I'm a one-man band, so a lot of this work involves some quite interesting contortions and gymnastics. So this baseboard was lowered so it met this level. Obviously the baseboards are different widths, etc. So this piece here was cantilevered out from the main baseboard. It's handy actually because as it's cantilevered out there's a slight bit of pivoting in it. So as a wooden shed, wooden baseboards, you're going to get changes as the weather changes. So you've got a piece of 2B1 underneath, and basically because it's a 2B1, as you slide it, pivot it, so you can use that to raise or lower within very fine limits the join here. This normally does not require resetting very often, but basically when I start an operating session, quick check of that and I'm away. Once it's set, it doesn't need resetting, hopefully for quite a while. Now, on the previous shot, the 280, when it went across that join, perceptibly rocked. I hadn't actually done a bit of forward planning and sorted that out. But now we've got the LMS Patriot, whacking it on, and away we go. Loco depot, locos are moving relatively slowly. They're on their own. The operating position for this is right, well, it's an arm's reach. So it's not a drawback by any means. And certainly the ability to have a reasonable sized loco depot that advantage far outweighs any very minor problems you're going to get there. And not so much problems, it's basically inherent in having a wooden shed. I'm quite proud of it, and as you can see, it's also a depository for all sorts of odds and sods. It is, after all, as I said before, my wagon repair facility and a parcels depot as well. So there we have it, yet another means of overcoming very, very limited space.